Hello guys, welcome to the channel. In this video we are going to see how exactly Python code is executed. Okay, so some of us say that Python is a interpreted language, but Python is a combination of interpreted and compilation. It is not just an interpreted language, there is a step involved which is called compilation. We will see that exactly in this video. Okay, so I hope you know some of the basics of the Python. You have heard about the Python language. So it has some rules, it has keywords, data types. Although we know need of mentioning what data type we are using, and Python is really very simple language, and we will see today that how its execution is working. Okay, so see, I have created some of the notes over here to make you more clearly understand what I am saying. Okay, so let's say this is a Python code that we have written. So to run this Python code, we have in a high level two components. One is known as Cpython, another one is known as PVM, which is Python virtual machine. Okay guys, so these are the two components that are present to actually run your Python code. In this video, we are going to discuss around this only, CPython and Python virtual machine. Without this, your Python will not be able to run. Okay, guys, so these are the two important components to run your actual Python code. Cool. So, what is exactly the CPython? Okay, so CPython, to run your Python programs, the Cpython is actually used to execute your program. So when you install your Python from the python.org, you are also actually installing the Cpython, because there should be some mechanism to run your Python code, right? So Cpython is that mechanism to run your Python code. Okay guys, so when you install Python from the website, the Cpython is also automatically gets installed. So what exactly is this Cpython? So Cpython is written in the C language, as the name itself says. It is used to execute your Python programs. And actually the Cpython contains the machine code of the C. It contains machine code. It doesn't contain the C program code. It contains the compiled machine code of the C language. Okay, that means the CPU can directly execute that machine code. So Cpython contains that particular machine code. Okay, so this was all about the Cpython. It is a large software application, and it contains lots of components inside it. I have mentioned in this yellow highlight: tokenizer, parser, AST generator, compiler, PVM itself, that is Python virtual machine. So PVM is also there in the C Python. Okay guys, so these are the some components I have mentioned: tokenizer, parser, AST generator, compiler, PVM, then memory manager, garbage collector. These are the all components that are present in the C Python. So C Python is the heart of executing your Python program. Okay, and as I said, it is compiled into the machine code to get directly execute on the CPU. Okay guys, so this was all about the C Python. We will try to break down slowly, and ultimately at the end of this video you will get clear idea that how exactly the Python is exactly executed. Cool. So let's go more deep into this. So see, you got the idea that Cpython is important to run your Python programs, and it is written in the C language, and it is actually compiled into the machine code. So Cpython actually having the machine code for executing your Python programs. But it also has some components like tokenizer, parser, all this to make more stuff, to convert your actual program into some another code. Okay, so we will see further that. So see, tokenizer is the first component that comes. So this is your source code. This is your source code of the Python, let's say, and this source code is having simple one line, that is x equal to 10. Simple. So what tokenizer does is it actually breaks your source code into small units called tokens. It breaks your code into small units called tokens, and these tokens look like I have written on this right side. These are the tokens. It says that identifier is x, the operation is use assignment operator, and the number is 10. So this is kind of a conceptually you can visualize that the tokenizer works like this. It is a part of the C Python. Remember this. Okay. So it is making the small tokens from your source code and writing in this manner basically. That these are the variables, numbers, these are the operators. Okay. And it doesn't understand your programming logic. Okay. It just see, okay, these are the lines we can build into this tokens, and it just create those small tokens. It doesn't understand the programming logic of your code. Okay, now next step come is the parsing. So the parser is used for that. After tokenization, now the parser sees what are the sequence of your tokens. Now the parser also sees that is there any error in your code, is your code is following the Python's grammar rules or not. It checks that, and if there is any error, any issue, then Python gives the invalid Python syntax error. Basically syntax error it gives if it any detects any kind of error or any stuff. Okay, so parser checks all the sequence of the tokens that you have created. It checks whether it follows the Python's syntax rules or not, and if it is following, it further pass to the next component. Now the next component is AST, also known as abstract syntax tree. Okay, now the parser converts the whatever your source code into the abstract syntax tree. Okay, so let's say this is again your source code. This has been tokenized, this has been parsed, and it is correct a Python code. Okay, then further parser does what, it converts your this code into the abstract syntax tree, and it looks like this. But actually I have shown a very simple implementation of this, but actually the tree data structure might be used in their internal code as well. Okay, so it's something simple way like this. The It is showing that x is variable, and in this variable the addition operation is used, then 10 and 20 are the operands of this. Okay, so this is the simple tree I have shown, but internally actual data structure is used. Cool. So parser creates this abstract syntax tree, guys. So after creating this tree, the next important step comes, and that is compilation. So most of you have heard that Python is interpreted language. Now you will get to know that in this there is a compilation process as well. Okay, so CPython is having the compiler component. Okay, CPython has this compiler. So after all these three steps, tokenizing, parsing, forming the abstract syntax tree, after all this, the compiler does what it converts your source code into bytecode. Okay, converts into bytecode, not machine code. In normally a C language, the compiler converts directly into machine code and it gets executed on the CPU. But bytecode is different and machine code is different. Machine code are your simple zeros and ones. Okay, but bytecode are the used for the specific virtual machine. Like for the Python virtual machine it is different, for .NET virtual machine it is different, for the Java virtual machine it is different. So bytecode is different for the different virtual machines. They are created for that particular machine only. It is not made for understanding the CPU. CPU will only understand machine code, that's it. Okay, CPU will never understand bytecode. So that's the difference in this, that in the Python's compilation process, the compiler converts the source code into the bytecode. Okay, it converts into bytecode. It produces the bytecode. Therefore, Python is not simply interpreted. The Python's source code is first compiled by the compiler. This compiler converts into bytecode. Okay, that is the important point you have to note. Okay, Python do have the compilation process. Now once bytecode is generated by the compiler, now what happens? This bytecode usually looks like this, something. Although the Python virtual machine may be using different, but this is how it looks. So see, next thing comes is the Python virtual machine. So see, in the starting of the video we saw that Cpython and Python virtual machine are the two important components I said. And further I also said that this Python virtual machine is actually the component, it is a part of the Cpython only. But what Python virtual machine does is it it executes the bytecode. Okay, it executes the bytecode. Basically, we will make it more clearer. Not actually, it doesn't directly executes the bytecode. There are steps. Okay, but it executes actually bytecode only. We will see that in a more better way. See, okay. So see what exactly Python virtual machine does. So in Python virtual machine, there is something called as the interpreter loop. Okay, there is something called as interpreter loop. Just a second, guys. There is interpreter loop that is present in the Python virtual machine. Basically, interpreter is present inside the Python virtual machine. What this does is, let's say this is a bytecode 1, bytecode 2. Basically, these are the bytecode instruction. So this interpreter does what? It first sees this instruction, then invokes the corresponding corresponding C Python's code. It invokes the C Python's code for your particular bytecode. Okay, so here interpreter is used. First it sees one line, then executes its corresponding direct machine code. Okay, as I said at the start of the video also, that C Python has the machine code of your C language. Okay, so this Python virtual machine is actually executing the C Python's machine code by interpreting this basically. Okay, C Python is interpreting your bytecode only, because for the corresponding bytecode, this your C Python code will be there that will be executed. Okay, and as I said, this is machine code. Now the machine code will of course will get executed. Now interpreter will get to the next line, it will see another. Now it will find out the corresponding machine code, corresponding C Python machine code, and it will execute. Then again it will come to the next instruction, it will execute this machine code corresponding whatever like instructions are there, like add, load, assignment operator, whatever, it will execute this corresponding machine code. So that's the task of the virtual Python virtual machine. Basically it finds out the machine code and it gives to the CPU. Basically for the CPU executes that machine code only. It invokes that C Python's machine code. That's the task of the Python virtual machine, guys. Okay, so I have written some points over here to get more better clarity on this. So see, the C Python's compiler produces the bytecode of your code. Okay, of your source code. The C Python compiler produces bytecode, and Python source code is first compiled. Okay, it is first compiled after all these three steps, that is tokenizer, parser, abstract syntax tree. After all these steps, further your first source code is compiled. Okay guys, now after that, for the bytecode is generated, it is passed to the PVM. Okay, Python virtual machine, it is passed to the PVM. Now Python contains interpreter loop which reads the next bytecode instruction and it executes the internal C Python code, and this occurs in the loop. As I said, it continuously checks for the next instruction, Python virtual machine, and it executes the corresponding machine code, basically finds out. Okay, I have even drawn this block diagram. So see, your first Python source code, it is converted into bytecode by the compiler. It is then given to the PVM. In this, compilation process is happening because compiler is there. Okay, then this bytecode is given to the PVM. Okay, and this PVM gives the corresponding C Python machine code, and over here interpreter is used. Inside the PVM there is interpreter which continuously checks for the next line of the code and it executes at that moment. Okay, basically finds the machine code, and further your CPU is there which executes that machine code. So this final diagram is sufficient enough, I guess, to get a better clarity on this. Okay, this is sufficient enough. First, Python source code, yeah, it is converted into bytecode by the compiler. Then the Python virtual machine interprets the bytecode and it finds out the corresponding machine code from the C Python, and then machine code is executed on the CPU. That's it. The story is over. This is how your Python is actually executed, guys. And I hope you got some idea. And so any confusion you were having previously, that might got clear. And let me know in the comment section as well that if I have said anything wrong in this video, please correct me and tell me how you like this video. And this was all about the story about the how actually Python's execution work. So this was all about the working of the Python execution. I hope you like the video. Thank you guys for watching the video. Bye bye.